And we are live. Welcome to the Country Club. I'm Walter. You're watching Kuntry 3D. Today we're talking with Scott Lahteine, the Marlin Whisperer, the Marlin Master, or whatever else you want to call him, just not late for supper. We're going to do this in normal fashion. I will have my interview with Scott, and then you will have time to post questions. So without further ado, here's Mr. Scott, a member of the Country Club, as you can see there. Go ahead, Scott. Take it away, buddy.
Hey, Walter. Thanks for having me. How's it going?
Good.
Yeah. It's good to be with you. Looking forward to Murph. We're getting ready to head out. I guess we're going to go out probably on Wednesday sometime, maybe early. Yeah. And try to get to Indiana. We're driving from Austin. Try and get there like Thursday evening and hang out for a day, maybe visit with TH3D, and then head over for, I guess, starts pretty early on Friday. So yeah, I want to get over there and just take it all in. I remember last year it was really exciting. It's you. It was exciting to be there. I was seeing all the rep wrap machines, especially. Looking forward. I'm hoping to see more of the same rep wrap stuff that we had last year. That presence was really a welcome thing.
I've seen a couple of projects that I am so looking forward to seeing. You know, and it's hard. You live in Austin. I live in Florida. There's really not any gatherings here for me.
Huh.
And there's no like Printed Solid or IC3D or Matter Hackers. There's no companies that, you can go to a meetup or anything like that, even close to me. How is it in Austin? I mean, do you have like local groups or anything that are there?
There isn't nearly enough happening here. I haven't attended any user groups or anything like that. There is actually a hackerspace, ATX. I think it's called ATX Hackerspace. It's on the side of town that I used to live on. I used to be able to bike over there, but now it's like I'm way down in the south side. So there's nothing that I found close to here. But I bet if I look around, there's probably something. But they didn't have any kind of 3D printing meetups per se. But I remember the last time I was over there, they definitely had a presence. They had a couple of Creality machines popping up, and they had some older rep wrap stuff, maybe even a cupcake or two. It was pretty classic. Yeah. So there's definitely some people are interested for sure.
Well, that leads me into this, okay? Because right now you're doing Marlin, and we'll get to that in a minute. But what path got you interested in Marlin or started on Marlin? How did you get into 3D printing or CNC work, whatever it was that got you into Marlin? What got you there?
Yeah, I mean, I come from a software background because I've done code since I was young, and starting out on like 8-bit Atari computers and working with computers kind of that are running around a similar speed to the processes we're using to run like AVR printers. They run at like 16 megahertz, so it's kind of a speed area I'm used to. But I was actually looking to get away from the coding that I was doing, which was a lot of like web coding and app coding. Get away from the desktop and kind of learn more about electronics and see, get maybe some robotics, have some kind of code running on something that didn't necessarily just interact with you through a screen and a mouse and a keyboard, but get into something a little deeper and see where that would lead. So coming from a software background, it was interesting because in electronics, you're dealing with, there is a lot of logic going on there at that electronic level. But what we're dealing with is a lot of mainly just signals. It's turning switches on and off really fast. So it doesn't, I haven't delved in like as a coder into the realm of like making my own circuitry from a coder perspective, right, where I'd be building logic gates. But from a software perspective, where I'm sort of controlling all the little gates, and then dealing with the devices, and they take care of like most of the heavy lifting is done by the stepper motor or by the driver of the stepper motor or by whatever device it might be. When we just get on the Arduino side, we get like the raw signals, and so it's a lot like coding in other realms where you're getting inputs and you're producing outputs, but instead of text input or voice input or whatever, and then some kind of screen output, you're dealing with, G-code input and moving some motors and creating heat output. And that's a whole different realm, but it's very appealing because I also come from making games, and I've always enjoyed coding where you've got something that is happening in real time and you have to respond to it, whether it's user input and moving some, enemy or something at them really fast and having it behave logically, or in the case of 3D printing, having to deal with the physical realities of the device itself, where, yeah, you could, just put out these signals really fast as possible, but you would end up with a mess. So you have to, attenuate that and have it all be tuned. And all of these kind of are very similar to me. It's very much that similar kind of real-time, interactive kind of coding. And so, yeah, it's definitely there's an affinity between both what I've done in the past and what I'm doing now.
Okay.
The 3D printing side of it, of course, came from looking for a project to do as a coder, getting into electronics. What are you looking for? And you, of course, quickly discover Arduino. And you quickly discover that, well, one thing that Arduino is used for a lot is 3D printers. And there's this RepRap project that Adrian Bowyer has done. And wow, isn't this interesting? Let's check it out, see what you can build. And as I went researching, I discovered things like, the Mendels and the idea of self-replicating machines. And that has definitely a huge appeal to a coder who's like, yeah, now I can take my code into the real world and have it replicate itself. I'm
taking over.
Yes, I welcome my new self-overlords. So it was kind of I think every coder kind of gets into code because they realize that they can control the machine and make it do their bidding, and having all that power at your disposal is just it's a very tempting thing for anybody. So, but being able to take that into the real world and then make 3D objects at the same time, you imagine something, you create a model of it, and then an hour later you have it in your hand. That immediately gets to you. And I think it's just, I have a strong interest in the whole, getting science, technology, engineering, math, and art kind of as, STEMA out there to the kids to really get education more hands-on. And, because we, certainly, I think just about everything we do, no matter what technology or what realm it might be in, there's some art to it. There's some technology involved. And this is one area that, is definitely good to know. I think one of the things that I see a lot in making is all these people who know all these skills. They have a little bit of electronics. They can do some sewing. They can, do some modeling. They can, maybe do some, molding and things like that. And all those skills come together to produce whatever it is you happen to want to work on. I think it's great that, code is considered sort of one of those sort of niche areas, especially if you're doing something highly complex, a big project like Marlin. But for little things, if you're just making a costume and you need your lights to blink in a certain way that matches the way it looks in the character in the movie, you could work on that for hours, coding it up and trying things. And, your program may only end up being 20 lines long, but, you've done something that, you've worked with a skill that is, part of the whole suite of skills.
I'm going to have to tell you, I have to completely agree. Coding is an art form because I've been behind people that couldn't paint and those that paint masterpieces when it comes to coding.
Sure.
I've seen some that couldn't paint by numbers and some that just can't stay inside the lines when they're using crayons. So,
right. Yeah. Sure.
But yeah, you're right about that. You're right. Now, how long have you been the curator or the mastermind or whatever you want to call it that you do with Marlin firmware? How long have you been, kind of over that realm?
Let's see, a week? I don't know. No, it's been a while that I've been doing it on a daily basis where I'll get up every day and just check the issues and go through the pull requests and things, which are, submissions of new code, and just check things over. So I've been doing that for a few years as both an adjunct to also helping others integrate Marlin with their stuff. So now I'm doing it sort of full time, pretty much every day. It's just, especially right now with the imminent release of Marlin 2, and Murph being one of those seminal events that you hope you'll have a release for or something to announce for. I hope to be able to say, by the time Murph comes, which is very soon, that we have something that's sort of beta quality, if not for most of the processors that we're targeting. And that's a challenge because always things are forward and back. But yeah, so anyway, to answer your question fully, it's been a few years, and it seems like it's just continuing to, there seems to be no end in sight of the amount of work that needs to go in every day. There's just continuous submissions. There's always things that we still need to do and have more full featured. There are a few I can think of off the top of my head that would be great to have that are still not completely there. There's still kinks to work out in some of the newer features, and there's just always something to do. So
Chris Riley jumped in and said, Scott and Walter, I can't stay, but I wanted to pop in and say hey and have a good show. Looking forward to watching it back.
Hey, great. Thanks, Chris.
He will be at Murph. We're having fun in the country basement table.
Excellent.
So we're gonna have that there. And
sweet.
So now, your interest really wasn't in 3D printers all that much to begin with, right? You started off with the Arduino stuff, or?
Well, I was looking for, as I say, I was looking for something to do, really, that would give me a chance to do some soldering and start practicing those skills.
I got you.
And so it seemed clear that if you were going to do that, the first thing you should do is maybe, if I was going to build something, it should be a tool maybe that I can continue to use in the future. And the 3D printer seemed like the most useful thing you could possibly build within the realm of the cost that I was kind of looking at.
Right.
A few hundred bucks to get all the parts together. And it was also the kind of thing where it was just, here's an open source design. You get the parts, figure it out.
Yeah.
And so, I went that realm instead of going and getting a kit from somewhere, just like sourced the frames from one place and the motors from other places, and I messed up, got the wrong parts, and had to try again. And I probably spent way too much on shipping, but in the end, I learned a lot. Ended up with some tools that I could continue to use and some spare parts, and basically, through that process, I learned and got what I wanted, which was to start getting into that soldering and building stuff, and burning myself and shocking myself accidentally and all that fun stuff. And
when you started on Marlin, I'm pretty sure you started like most people start. You're doing a little piece like, hey, I can improve that, and you do a pull request and blah blah blah.
Yeah,
I'm pretty sure you got started in that way. But when you started and you delved into it, I mean, did you see yourself moving in the direction that you are now?
Initially, no. I mean, not per se. I mean, it was just, it has always been it's a group effort. And, I would say that my part of it is like sort of the more tedious part. I'm willing to do the tedious stuff of going through all the issues and seeing what needs to be fixed and just fixing it. Working with someone who's trying to either create or fix something and help them through that process. And so it's sort of just, that part of it is just sort of comes out of my nature of just wanting to be like, helping to integrate what is there and sort of taking a bit of a parental side to it. As far as the point where I actually got to feel a little bit parental about it, it took a while. It was because it has always been a collaborative thing, and I was just one other collaborator, and I still very much in the sense that I'm contributing code. I'm just another collaborator working with trying to get things integrated the best way we can. And so from going from that to sort of being like the daily go-to person for collaboration and getting things in, that initially took a while because it was just, felt like I had other things going on, and it was just something on the side that I was doing. And it was just sort of as I needed to change things. Initially, I would find something I needed fixing, I would fix it and contribute that, and then I would go away for a while. And then it became, let's talk about what needs fixing in more the general sense. And then there was just a lot of cleanup. And so it was just sort of like sort of getting the code into a shape where it looked like something that fit what, sort of my standards of quality, at least, or at least spacing. The overall, like, what it could be is sort of limited by where it's deployed. We have that AVR problem, and so there is like the possibility of, like, all these other firmwares have a certain advantage in that they have very narrow targets, and so that they can be a little more expansive. They can be more modern in their code style and stuff. But overall, like, getting into that position where I'm like sort of thinking about these bigger issues and trying to define what Marlin should do and how it should develop, and sort of getting everyone together, is, a lot of it did come out of just the willingness to do the tedious bigger jobs and weirder jobs, like refactoring, dividing up the code into lots of little files, for example, was a big job, and arranging it into folders nobody really wanted to get into, and I had the willingness and enough attention to detail to be able to kind of do that.
Yeah.
And so I think little by little it just came out of being clearly just having a sense of the overview, being well versed enough in many areas because I've touched so many parts of the code, and sort of all of those things come together to make me a better or a good custodian of the code. And insofar as anyone else is gathering those skills, like, they can sort of join in the process and help along. And then things like the documentation also come into it, like the willingness to, as you go along, like, okay, now that this thing's been integrated, now I have to write up the page on the website about it and make sure that it's correct and everything matches up. And, again, it's sort of like there has to be one person who's sort of like going through living in the mansion that is Marlin, and kind of like dealing with all these parts and putting them together. As much as I try to bring in help, it always comes back to, I end up being the editor anyway. I have to read what they've done and make sure it conforms and correct the things that are a little off, or change the phrasing so it's clearer, or whatever it might be. And so, it's just, you can tell I've got like this, I'm very much the constant gardener of Marlin, like just tending to the weeds. So you can always find me in the garden. And so, the people assume that I planted the garden. I really am just, the garden has been here, and I've just been sort of tending to it all this time now. And I'm willing to continue doing that. So
I've got one more general question before we delve into a little bit more technical stuff here, because I have some pretty good questions, and I've actually gotten a couple out of the chat while we've been sitting here talking. I've been copying and pasting them in here. But okay, you talked about the collaborative part of it, and it's great that that's the way it is. How many people would you say on just say at this moment are actually collaborating on Marlin?
Yeah, as far as people working on and thinking about issues and who have things that they're maybe even waiting for that they've already submitted, it's probably in the realm of about, I'd say, 24 on at any given time are kind of like filtering through, and half of those are very active. So we have it wasn't always that way. There were, a few, and then, and people have come and gone. There was a core team sort of initially that was very hands-on, and they sort of came and went as Marlin kind of, became its own wild beast for a while, as it was getting reorganized, especially. And some of those people still come around and come back, and it's interesting because there's a whole rotating cast, and at any given time, there's a few people right now who are very much paying close attention to certain things, like the STM32 processor, or taking care of user interface stuff. The guys from LF Objects are especially attentive to the UI and things like that as they're working on their side of things. And so there's and as far as the number of active, say, companies and corporations who have people who they dedicate to working on and collaborating with us, not as many as you would think. Maybe one or two.
No,
but
I get it. Actually,
yeah.
Gusner asked a question. He said, Scott, would it help if you had 2 or 3 reviewers to make your life easier? The problem is, though, you said you're the gardener.
Oh,
So,
yeah, right.
you know, now
I
you're
have to
talking
review
about,
the
okay, now I
reviewers.
need assistant gardeners. So you have to review the reviewers, right?
Yeah, well, who watches the Watchmen, right?
Right.
Yeah, I mean, that's always the thing. What I really need is just people to sort of take the other things off my hands so that I can focus on the core element of integrating all the new stuff and making sure that it all fits together. And then, you know, things like the hardware access layer initially is very much a wild creature that is all just being developed by many independent entities. And so there are things that it has that are maybe reproduced, and like things like I want to be able to bring those together and clean it up to reduce the amount of redundancy and things like that that are kind of like elemental, but may not necessarily show on the in the final product, like as a new feature, for example. But I'm also helping with those. But generally things like documentation, maybe we did try some experiments with like having people help with the issue queue, but that tends to make the issue queue useless for other things. So what we're just going to follow a policy of closing issues as they get stale, say a few weeks without activity. We'll just close it if someone complains and says this is still, I'm working on it, reopen it. That's when we can do that. But closing them makes it a little easier because it goes away without us having to see it pop up in our notifications all day. So whereas if you're going in there and asking, hey, how's it going? It goes to the top, and then I have to read, hey, how's it going? That doesn't help me. I'd rather read the issues that are active and things like that. So yeah, things like that are important.
Since you mentioned it, I've got a talking point here for you. Can you talk a little bit about the integration of the MMU2 into Marlin?
Well, someone did submit integrative code that brings it in and adds a lot of settings, including things like your how your ramming moves behave, speed-wise and length-wise. So you can set up all those things inside the config. So as far as I know, if you have an MMU2 and you have a Crowd ECR10 and you want to attach your MMU2 to a Crowd ECR10, you can do that now by using Marlin 2.0. Yeah, right. And it just, you know, it talks to it in all the, basically it's essentially ported over directly from Prusa's code.
Right.
So it is essentially the same thing.
All right, since you mentioned 2.0 now, there's another question here. What's the status on 2.0 being officially released?
Yeah, well, it's, you know, it's as an open source project and working with the Scrum Agile technique of development, which basically means very open-ended.
Right.
We set sprints for certain things, like we're trying to get, you know, STM32 really solid right now, and so we have to devote some resources to that. So each thing is like, you know, there's a checklist that and milestones that we can say bring us closer. I would say that right now, for certain setups, it's pretty complete. You could probably use it on most LPC 1768 and 1769 based boards like the MKS base and your smoothie board, and you'll have almost every feature supported fully. Some of the STM32 support is becoming more solid all the time. We've been dealing with some just, you know, compatibility issues there that confused us, but brought it. I think we're solid on that. It was like timers and things, PWM, and basically for AVR, I would say it has parity with 119, and then it also has extra stuff like the menus have been somewhat reorganized, and there may be some changes still coming for that, but overall, I'd say for AVR 2.0 is you know, in a very good beta. You know, I'd say maybe even better than beta. I would say it's better than 119 probably as a choice. I'm not sure if the build size is different because it is organized into many more files. It may be a little bit because of the way the linking works, and that may affect speed slightly in the higher level code. But for the lower level stuff, like the steppers moving fast, we want that to be as fast as possible. So we've tried to avoid any changes that would impact that. For the higher level code, things like talking, dealing with certain G codes or doing the menus and things, we don't mind a little bit of a delay or wasting a little time because the steppers will still move just as fast.
Right.
So we try to keep that. But overall, yeah, I'd say 2.0 at this point is it's maturing, and it's going to be, I'd say, when could we call it, say, an actual beta or release candidate?
Yeah.
I wouldn't rule out by, say, the end of the summer. It depends on how quickly we can move on some of the platforms that we're dealing with, especially the STM32, which is just because it's so new and unfamiliar, and the things that are based on it are new and unfamiliar. We're just dealing with that. And then, of course, the quirks of 3.3 volts versus 5 volts sometimes trips us up, and other little things like that. But I would say we're getting closer all the time, and we have a lot of stuff being submitted that is like new feature-ish. But I'm hoping that I can get some of those folks to devote more resources to shoring up the things that are still like just going to get us to that point of beta release. So we'll see how that goes. But I'm optimistic that we'll have one pretty soon. So it's worth working with now. I'm actually running 2.0 on all the machines that I have here. So yeah, it's working for me, and it's partly to test things, but also just to really prove that it still works, and and shore things up, and just these are all AVR based for the most part. I have one very challenging machine. It's a tool changing device from E3D that runs a Duet, and that's going to be, even though Do is one of the better supported platforms we have, it's a very complicated one because it has tool changing and and standby temperatures and other things that we just have to add.
Well, that's one of the things. That's one of my questions down here. But first, before we get to that, what about touchscreen support, and what are the challenges that you have with touchscreen support in Marlin?
Well, touchscreens, all for the most part, each one is different. They don't all necessarily speak the same language if you're trying to tell them how to update. They all, for the most part, connect by a serial plug, so you can just basically send text commands to them, and they may respond or not. But they also generally work by sending G-code to the machine, so it's kind of like having a mini host. And so they're limited by whatever can be done through, as far as interactivity, what can be done with G-code, and we can't necessarily add to them. So if you wanted to have, say, the full menu system of Marlin on a touch screen, if the screen was big enough so you could touch them reliably and scroll it and do things like that. Right now, there are no screens that permit that, but some are maybe being developed. But overall, yeah, the challenges are mainly just dealing with how do we talk to it and getting all the protocols down, and then coming up with a nice unified interface, a way for different touchscreens to all be integrated by using the same system. So we have this thing now called extensible UI, or EXT UI.
Yep.
That's in there, and that can be built on. And the idea is that you basically subclass it, or basically implement it. And by implementing this, you get all the things you would need to be able to communicate back and forth with Marlin. And Marlin will take care of the stuff like getting the serial connection up. And you just have to write the things like how do you tell your screen that the XY coordinates need to be updated? So you send that information, whether it's in JSON or some other weird format. So it's like, it's basically the challenges are being met, but a lot of it is with the help of Aleph Objects and Marcio there. And so that's been, I've been like trying to hold my nose as we've been going through it, because I'm never sure if this approach is the right approach, because it's a sidecar to what we have as sort of the core UI, but I'm thinking of it differently now, where the core UI is now more of a sidecar, because it's just dealing with screens that we have to manually update, like the character display and the graphical display, where Marlin is responsible for sending all those bytes to the display.
Right.
We don't have to receive stuff back except a knob twist, which is nothing, or maybe a button push. But one of the things about these serial displays is they do take a lot of the load off of Marlin, since it doesn't have to do that display update stuff,
Right.
except when, maybe something changes. And then it's simpler. It's just a serial message, just like putting it out to the console or the host.
I have to agree with Repcord. JSON is not a weird format. You take that back.
I said JSON or some other weird format, which I would say.
Well, what are you talking about? What, XML, YAML? What do you want?
YAML, yes, it should all be YAML.
No, it shouldn't. Shut up. Eddie Moser's over here going, YAML's good. No, it's not. Shut up, Eddie Moser.
No, I actually prefer JSON for its compactness, and I'm actually implementing the panel do support, and it uses a JSON protocol for everything. So
right into the next question.
Yeah.
Are there any plans for a branch of Marlin compatible with like the Duet web interface?
Well, it's interesting. There's one of the ESP32 Wi-Fi has just been added, so that's actually that actually puts a web folder into Marlin. So you're just talking directly to the board when it has a web interface in it. So certainly, if the Duet web interface is similar in that regard, it's a folder, and it kind of deals with that side of it. And then we just have to do that side, so the firmware side. So I'm looking a lot at, especially because of the tool changer, and wanting to get support in there for that. One of the pieces we have to add is, dealing with the web server on that board and on the Do X5, and the interface with those. So and again, each of these things is a little piece, but all of them will add up together to hopefully give us a full ability to run a tool changer with Marlin.
And I'm sure I haven't looked at the Duet firmware, and I really haven't delved into Marlin that deep, but I'm pretty sure Duet has some type of web API that the web interface calls.
Well, it basically it's got an entire website that is just on the board,
right?
And you just and so as long as the basically the web interface for that is fairly standardized, so we could just take that piece almost verbatim as it is and bring it over. The tricky part is that it's written specifically for Duet only, and so that's one of the things which we would, sadly have to say, well, sorry, AVR people, you don't get this.
Yeah.
But again, it's the same with anything. Same with ESP32. You can't have that Wi-Fi on there either. So it's as we bring these things in, it makes it sort of, again, more like an add-on. And so how do we bring these add-ons in a nice, elegant way? And in a way that will be like, if the next board comes along with a Wi-Fi interface, can we do the same thing? And I believe we can. For most part, the big challenge, actually, I've been playing with that interface, and I like it a lot. I've been told that the Octoprint interface is better by some. And I wouldn't be surprised if it is, because it has a lot more, rapid and development going on.
Well, but, it's got so many plugins that just make it so much more versatile.
Yeah.
Don't get me wrong, for just a straight up interface, I like the Duet web interface, but for extensibility, as you said a while ago, the Octoprint interface is a better platform, I think.
Yeah, and like the one thing is for sure, like I would love to have all the things that basically almost indistinguishable on the Duet running. Like you wouldn't be able to tell it was running Marlin. It would just be the back end side. But yeah, we have so much we have to fill in. We've got things like the standby temperatures. Some of the dialect is different, although you can set rep firmware to run its own, to run in a sort of a Marlin-like dialect. There's some things that are a little different. Got a few things we just got to fill in. Got to make, G10 be smarter, so it knows when it's which kind of G10 it is. Other things like that. And yeah, just all the pieces have to come together. But I'm really looking. The big challenge for me is bringing it in and making sure it doesn't disrupt the rest of the platforms, and also opens up the possibilities for other platforms to do sort of the same stuff. Like the same idea with, like, say, MMU2 is, we we want to have it work, but not just with the Prusa i3. If we could bring it in and only have it work with i3, that wouldn't have been a completed feature. It should be generalizable, and when we make it generalizable, that sometimes means it gains some customizability, but also it isn't as easy. But no, with the Prusa, you can just boot it up, and it goes through a whole startup process and tunes everything and figures out the points on the bed and all that stuff. And so a lot of stuff is not yet into, in Marlin, because that's the polish that say a vendor would have to add to their version of the firmware to make it a complete product. We kind of offer the starting point that we offer the pizza crust and the toppings in a frozen bag, and then you have to put it all together to kind of make the final product.
And that kind of leads me into my next question. And I know you're working on stuff for the E3D Tool Changer, but how close do you work with vendors like E3D on the E3D Tool Changer? I mean, how close do you work with them?
Well, as close as I want to, honestly. They have a Slack channel, which is very active. And of course, they invited me to their beta program and sent us their tool changer. So we have this behemoth, which is a beautiful machine, which is basically wins the contest in terms of rigidity. I've never met a more rigid printer or solid printer in my life, and opens up some very interesting possibilities. With the tool changing stuff, actually, there is tool changing in Marlin now. So if I could get a very bare bones Marlin running on the Duet, but without all the Wi-Fi, without all the other bells and whistles. But it would really be, I guess, it would be like the very sad version of what I've got now. And I really I want to work with what we have, and so and give feedback to E3D. So actually, trying to work with that machine more and give them feedback and basically mostly get help through the Slack channel. But they're actually very active. They sent out, I don't know how many beta units, but there are a good couple dozen people on the Slack channel discussing this stuff and dealing with the issues and helping them to develop their next version. And so it's a very, very smart thing for them to put this out to the community. And, when I first saw the machine, I was immediately blown away by just the amount, the idea that, oh, well, yeah, you can have them all be different temperatures, different materials, and have that, as an engineering tool is just amazing to think what you could put together with that. So I was immediately excited by it. And when they promised to send me one, I kind of thought they were joking, but no, they're very serious about having something which is open, and which and they would love to see not just their version of RepRap firmware with the slight tweaks they've made to it running on it. They'd like to see Marlin running on it. They'd like to see other firmwares running on it, because they're just offering the platform and the concept, and they really want to see what the community is going to do with it. So
I got you.
Yeah, E3D is fun. It is just great that way. I expect they'll be at Murph, so I can buy Sanjay a beer and thank him for sending this unit out to us.
I hear you. Now, what do you think about, or have you looked at, or played around with firmware like Clipper?
I haven't looked at the source code of Clipper. My understanding is it runs on a BeagleBone or something like that, or maybe a desktop too. Because I guess it could run on any version of Linux, I suppose. But they get the concept there. I've been kind of discussing this with my cohort about whether how to best create something which would be a compacted or optimized version of G code. Essentially, the instructions to the machine, which are very general. It's when you send G code, it just says move X here and Y there and do it fast. And it's up to the machine to decide, or the firmware to decide from that point forward how it's going to do that.
Right.
But it produces it's a deterministic machine, essentially, apart from the fact that it might respond to temperature fluctuations and change its speed accordingly or something like that, you could essentially run the same G-code 100 times and it should produce exactly the same pulses to the motors. Even if it was like a 7-day long print, you should get precisely the same graph if you were to graph out all those pulses and have them line up exactly. It's a deterministic machine, and therefore you should be able to run the G-code through, take all the blocks that it would have produced to tell what the stepper motors what to do at the lowest possible level, and output that as a file, and have that. Sorry, I'm excited. Output that as a file, and actually then run that later on and have it just go straight on to the stepper motors and skip all that G-code parsing rigmarole. And theoretically, you should have a faster machine as a result of that. And that's the Klipper approach. It takes what you would get as your lowest level signals to the steppers, or at least close to it, and the blocks that it would produce, and outputs that as a code in itself. And can it be more, it doesn't necessarily even have to be more compact as long as it is more optimized. I mean, the compactness is important in the sense that if you're running really tiny moves and lots of them, and each block just describes that move, if you are running those moves too fast, you're going to actually have the planner get starved. It's still waiting. It's waiting for the G-code to be able to supply it.
Right.
So it's when you have a slow, input from your serial buffer. So you can do things like double your serial speed and see if that helps, and that generally will, or run it off an SD card, which can be faster, if it is faster. Sometimes they are. Or use some other method to get the G-code in there, or figure out some way to compress it. And so we think about how you can compress G-code, and there have been some proposals. There's actually a proposal on the RepRap website, the wiki, that could be implemented. Is it more optimal? I'm not sure. The thought is that if you discover in your encoding that, say, shrinking a number makes it actually bigger than the number itself, like as a single character, like the number 1 is just 1 byte. But if you're going to compact every number as 4 bytes, then sometimes those numbers will be bigger. Yeah. So you've got to have your compression code say sometimes the number is just a number, sometimes it's 4 bytes. And so you can switch off as needed when it seems like it'll be bigger or smaller. So you can do all kinds of tricks like that to compactify it, make it less human readable, but at the same time more machine digestible. And then it's just a question of, is it a trade-off? Does it actually save time, or is it slower? And does it get closer to the final result? So I'm excited by what Klipper is doing, and others have proposed similar things. We have a thing called chunk, I guess it's raw chunks or whatever, which basically would be like C codes instead of G code and M code. They would send a C something, and then there would be followed by that low-level info, and that would bypass and go straight to the planner without. And yeah, that's all possible. So it would something that I'd love to see implemented. And I'm playing around with a lot of like parsing kinds of stuff myself right now. Just so it's the sort of thing that it wouldn't be surprising if I were to jump into that at some point. So we'll see. Now,
I've got a straight up Chris Riley question for you right here.
Oh.
What are the risk advantages of sharing a load between multiple devices?
Well, I've done a little bit. There's actually a post on the Marlin issue queue where I discussed like how I implemented an I2C interface to talk sort of in a general way to talk to a second ramps board, which just handled the Z-axis, the end stops for the Z-axis. So yeah, the motors, the end stops, and basically the homing and leveling for a machine that had four corners, each one supported by a screw.
Oh wow!
And so the idea there was to be able to level them, and you would tune what your end stop offsets were, and it would do all that automatically on a second board. And then, since the Z-axis doesn't need to move all that much during a print, you would just send an I2C message to it to do the movement during the print. And it would handle all that on that second board. And so that removes some load, And so the trade-offs are, if you're going to do that kind of thing, you need to make sure your boards are connected using some kind of protocol that makes them respond quickly enough. You don't necessarily have to use I2C or serial. You could simply connect up 8 free pins and use some kind of parallel, interface that you design yourself. Because I2C, and it's like they're just waiting for pins to, or SPI in particular, you set the clock. So you turn the clock bit on and off yourself. And if you're running in some kind of weird thing where sometimes you go fast, sometimes you go slow, SPI doesn't care as long as you're not going too fast. It just waits for the bit to be on and then to be off again, and it knows that you've changed the state and that here's a new number for it. So you can design protocols, and just I'd say that the trade-off is basically that you're just going to have to do something clever to get stuff over. So one thing that's been proposed is to use a second board just as the screen controller. And obviously with touchscreens, we've seen that as a proof of concept works well if you just use it as a second serial port to send commands to your firmware. But if you're using it, if you wanted to build something a little more comprehensive and use, say, a teensy board for it, so it would be nice and small, and attach a regular graphical display to it and make it really smart and do all the things that, we'd love to see done, but the firmware just can't do because it's too much work and takes up too much time. Like you could probably conceivably do that and have it work really well. And that's the kind of thing that would be lovely to move off of your main board, because it's so secondary to what you really want to be happening. Like, you don't really want your board to have to do the screen updates. What is this, an Atari 2600? You want to have it devoted to doing all the important work of moving stuff, maintaining your heaters, and making sure that the machine is moving smoothly and all that stuff. And that gives you the ability to like maybe go up to 32 microsteps where you were using 16 before, or do other fancy things. And it goes kind of in the same spirit of taking on the smarter stepper drivers that you interpolate to 256. You can now go back down to 16 and you still get better smooth performance because those boards are taking the load off of the main processor. And anytime you add little peripherals that do that, you're basically adding value to your old AVR board. So I definitely encourage anyone who wants to take some more load off and put it onto a second board, or make something like a universal teensy graphical display interface that Marlin could talk to and still do its fancy menus and have them change from firmware version to firmware version, but yet have it all be handled in a separate way. That would be pretty cool.
I got you.
So yeah,
that now I'm gonna tell you that ends my questioning, but I've already copied like forever's worth of questions out of the chat. So we're going to have to get through these because, normally I do this for an hour and we go over a little bit if it's, if it's feasible. But, an hour sometimes just you run out of an hour and you're like, what? That was an hour? Really?
Yeah.
So, all right. 3D Gustner has been killing me on the questions here because it's hard to keep up with some of them.
Well, I'm sure they're good ones.
Well, what would be your favorite new processor to get Marlin on? STM, ESP3286? I mean, what would be your favorite? What are you looking to get it on and you can't wait to get your hands on and get it on?
I mean, I'm excited this is probably a stupid answer, but I don't know. Maybe a cop out. I'm really excited about all of them because just from the lowly do alone, it's already 5 times faster than the AVR. So you can already add a bunch of stuff to it right away. You've got all that extra RAM, you've got all that extra flash space. Like, they all excite me. I think one of the ones that excites me a lot is the teensy boards and just that platform, because they're such a small form factor. I believe I haven't looked too closely at it, but I believe there are like 4 or 5 layers in those boards, which is what makes them able to be so small. They've got the traces are running through all kinds of clever ways. And so I like the idea of having the controller be tiny and the supporting electronics that are like, maybe closer to the stepper motors. And so, things are more distributed. I'm excited by the idea that you could have a machine where the electronics are almost invisible,
Right.
So that's kind of cool. I really like the the expansiveness of the Duet and its Duet X5, the fact that you can run all those extra steppers and all those extra heaters and do something like a tool changer and have a web interface at the same time. That's all pretty exciting. Some of it is a little bit of a bummer because like now that I have all this power, it's almost like, well, I'm just working on like something that's almost a desktop system again. And like, there's no limits, you know, and the limitations are what kind of force you to be creative and work out things. And it's like some of all this extra power and all this extra space means that we can be sloppy, and it's not going to cost all that much. You know, you won't notice a performance drop if we happen to write really bad code because you're running on a really fast processor with cycles to burn. But the fact that they have those cycles to burn is it's exciting because you can actually maybe open up possibilities of some devices we haven't thought of. Lasers, they like to run at like 30 kilohertz or 25 kilohertz or so as their duty cycle, or as their base frequency, and you run your duty cycle on top of that. Those devices, you know, are peanuts. An AVR can run those all day with its PWM, but some of these new devices can run PWM at even higher frequencies, and so the kinds of things and devices that we might see come up in the future, yeah, it should be interesting. I'm interested to see what those will do and what they can support. Right. And then, of course, the kinds of features that you could do. Onboard slicing, I don't know. I suppose you could just drop your STL on there, and it could slice it for your specific machine. Those kinds of things may be up and coming because it's just a matter of, you know, bringing that logic over.
Now y'all heard it here first. Scott's putting onboard slicing in the Marlin.
There you go.
Y'all get to writing your profiles.
That's right. So don't forget to donate. Otherwise, it'll never happen.
I hear you.
Yeah, no. Like, share, and subscribe.
All right, so I'm gonna ask one more from Gusner, and then I'll ask some from some other folks, and then come back to Gusner's other questions. Which do you like better, the CoreXY or Cartesian XY head, and the pros and cons of running those on Marlin?
Yeah, well, CoreXY is not very taxing. It doesn't require much extra processing. It's just addition of subtraction, maybe a little division by 2. So very simple kinematics. The people really like the CoreXY layout with the belt setup.
Yeah,
I mean, it can be more compact, and it's probably better for your XY head C moving bed kind of concept, where your XY gantry is handled. There have been some XZ ones which are interesting. Yeah, I'm not sure what the added value is outside of like if you need a certain form factor. I wouldn't force a machine to be CoreXY if it didn't need to be. And Cartesian has a certain elegance to it. But the one thing about the Cartesian is that and maybe CoreXY does this better because of its distribution of the power a little differently between the two steppers, is handling things like combination XY movement maybe smoother or different than you get with where if you've got when you're on a Cartesian, you can always tell if the X is messed up. You get X artifacts or whatever, or if the Y is messed up, you'll see certain banding on that side on your cube. I believe with the CoreXY, it's less obvious, and because it's not necessarily connected to a particular stepper or a particular axis, they kind of combine a bit. So
yeah, I've got one right here that's printed, and it's a pain in my butt sometimes.
Yeah. Well, it's a lovely one though. But I like the aesthetic of CoreXY a lot, and I think it's clever as in general, the idea of combining the steppers in that way.
Yeah.
But it makes watching the steppers a little more interesting too, because like they move together or only one moves, and it's peculiar stuff, but it's cool.
Techie Dad asked, might there be a migration tool for upgrading to new versions?
Well, it's one of the things that is being worked on a lot in different fronts. Like just there is actually, one of the things is that 2.0 is still a bit of a moving target, but you could imagine, say, something that goes from 1.16 to 1.19 and just converts your settings if there was anything that changed, and there may have been a couple things that got renamed or moved. So the idea would be to have some kind of template that you could pull from, that would describe what your original config looked like, and then how to move those settings over to. The low level work of that is just producing those conversions, some way to like describe how it goes from one to another, and then actually the tool to do that conversion.
I got you.
And so I'm trying to approach it from a website approach, like writing in JavaScript the code to do that conversion, and then produce a page there you can just drop your file on, and then it would give you the download as a zip, without having to use any kind of external web server. And I've gone pretty far with that, but I'm kind of like bogged down in the idea of having a thing that can just parse everything and tell me what all the settings are for any given set of settings, and then from that be able to use that data. So I'm sort of in the process of collating that right now. But yeah, it's an extra piece of work, and I know a lot of people would love to have it. But ultimately, the simplest settings, your most base settings, are easy to move over because they haven't changed much. And there are only one or two things like, I think we reduced acceleration or jerk. I think jerk changed it went down by half between I think it was 110 and 111, or 112 and 118, or I forget which version, but at some point it went down by half because we borrowed Prusa's jerk implementation. And so, there was that one thing, but mostly the settings are going to be the same, and you can just move them over because the names haven't changed. If there are peripherals or add-ons that you had, like sometimes things like your, if you had advanced pause and stuff, some of those settings changed a lot. So yeah, that becomes a bit of a hassle because the names actually changed. So it'd be nice to have a tool that could just move those values right over.
I don't like it when you do that. Stop changing names of things.
Yeah, sorry, but
we're lagging.
Sometimes we're just trying to, changing things. I know it's the worst. It's the worst.
All right, so he had a second question, and like I said, there's a bunch of these questions, so we're going to try to get through them. Will there be any push for 3D printer slicers that will make use of G2/G3 if it's enabled in Marlin?
That's a question that I can't answer, but I hope so. I mean, I'd like to see if slicers do that, but it is a trick. And the thing is that you don't know that you've got it on. So the problem is if it would be great if slicers would, so you have the option. But it is tricky because they're very much oriented in making a lot of little straight lines. Yeah. And usually the way it's described is in the literature is that if they can figure out that there's a curve, they'll replace it with a G2 or G3. And it sounds like that would be a piece of work to be able to determine that a curve is actually perfectly circular and not not logarithmic or some other shape. So, but you could, it comes down to these kinds of approximations, and things like those involve trigonometry and would slow down a slicer considerably. So my thinking is it would be great if the model itself already had curves in it. Like if you use an STL, for example, or something like that, not an STL, but SVG, right? That describes things as curves. And so you could see, for example, that the curve has the same tangent throughout the entire curve. Therefore, you could convert that into a G2 or G3. So you could imagine it being done for laser more easily than or engraving, much more easily than for 3D printing. But yeah, similar things apply, though. It's definitely a challenge for a coder out there. I'm sure the Prusa slicer guys, they're probably working on it. They'll get it working.
Well, all right. So that was Techie Dad's question. Robert Reynolds asked, "Is there any way to get crash detection with the TMC 2130s like the MK3 has?"
Yes and no. I mean, the feature was recently. The ability, as it were, it was recently added to the the stepper library that we're using by Timu at LUT. And he has just done that so recently, and so it's being explored, but there are some challenges to that because false positives are a hassle, and they're all too common without careful tuning.
Right.
The great thing about the Fuchsia i3 is that they can tune things at the factory and really get it dialed in for their machine. With main Marlin, it's going to be up to you to tune it at your factory.
Right.
So, so if you can get it tuned really well, so hopefully what we'll do is we'll be able to provide a tool or an option within Marlin that would help you tune that. So now that it's been added to the library, we're going to explore that more. And I mean, we already have, the end stopless homing, so, or homingless end stopping, or whatever it's called. But yeah, no switches required for end stop homing. So the next thing would be to do like, if it detects a bump, then it should be able to stop. The tricky part is, just making sure that it's not false. And there is a lot of vibration on some of these axes, especially your bed.
Yeah.
So, so with big heavy beds, maybe not. We'll see.
All right. User Howie50 Ash, any idea on IDEX, Dual X, Dual E driver support?
Yeah, we have a lot of that, and it's getting better all the time. So give it a try. There's actually just recently it went from dual X carriage to multi X carriage, so you can have a few of those now. And we also improved mirroring. Finally, is now added as one of the options, so you can print a mirror print of things.
Yeah.
So if you need, the two of the Z ends, you can print them simultaneously. And yeah, all that stuff is in there, and it's constantly being improved. So please give it a try. Let us know how it works, and let us know if there's any bugs or things that could work better. The one thing I want to see work best is keeping the limits. So if you try to move these things, they won't bump into each other or go off the build plate or outside of the physical limits. And so if you're using software end stops, we try to, if you change from one head to another, we try to update it so that now your movement limit is here instead of here, and keep everything up to date. So I want to make sure those are working solidly. So please exercise them and let us know if they're working well.
All right. Chris from Practical Printing asks, how much efficiency is lost at runtime with the new Marlin 2.0 HOW architecture versus RRF firmware, for example? Resources, memory usage, that type of thing.
Like on a do, well, does it really matter? It's running 5 times faster. No, I would say there's actually, it's not like there's a translation layer that is like an emulator. It still goes directly to the hardware. And that's kind of the essence of Marlin was, since we were already doing everything directly to the hardware through what we call fast I/O, which is a bunch of macros that directly manipulate the ports and bits in the ports instead of going through the functions in the Arduino library, which incur function call overhead, plus they do some logic and other things. We try to do as much direct manipulation as possible, so we carried that over to the HALs for the other processors as well. So in fact, compared to other firmwares, it may be more efficient. And probably in many regards it is, because everything is done, all our linkage is static. There's no virtual classes or objects of any kinds. So there's no virtual function overhead. There's there's no overhead associated with maybe using fancier C++ coding practices that we've not done, because we're basically trying to keep everything static in Marlin. So I would say that most likely it performs as well or better than your common RepRap firmware in the same architectures. So
okay,
yeah.
All right. So user Scott Worthington asks, would G2, G3 be easier on the processor than the ton of tiny moves that we're getting with G-code?
Well, G2 and G3 will save you time on the front end getting the G code into the, from the serial port. So it is a single command that generates on the order of many times hundreds of tiny moves. So although it saves you on the front end, it may not be by a lot, because one of the things that happens is that your G2 comes in, and then maybe it's got a couple of G2s and G1s behind it in the buffer. And those things can't go out of the buffer that on the incoming G-code buffer until that G2 is done doing its move. And so it just holds up the host, and host waits for that move to be done before it can continue to send more commands, assuming the buffer fills up. And most of the time the buffer is only 4 commands. There's space for 4, and you can change that. Some configurations set it to like 10, but each line that it sets aside space for is like 96 bytes. Yeah. So most of the time your lines aren't going to be that long, but that's how much it sets aside. So, you know, there's that issue. So in general, there are trade-offs. G2 does generate hundreds of tiny moves, and on a like a delta, everything generates tiny moves. And if you're using bed leveling, everything generates tiny moves too, for the most part. For the most part, there was an exception, and may still be, with I think unified bed leveling, where it will generate moves between points as straight lines. So from here to here will still be a straight line, even though there may be dips in the bed along the way. It'll divide it up by the grid points, and so you get maybe 5 moves out of that. But oftentimes your moves are getting divided up without you realizing it, and so those things. And in general, it's not that the machine itself is slow. You can actually, even with your AVR board running at say 16 microsteps, you can push your machines these days way past their physical limits and much faster than you would ever want to really use them.
Right.
And even with dividing up moves into tiny moves, it's so the real bottleneck there is being able to move things through the throughput. If you could print faster, it would be nice to have the throughput be faster to keep up with it. So that's the essence of it. If you don't want to ever send lots of tiny lines, and so I agree that like G2, G3 is a better idea, because that'll keep certain types of stuttering from happening. But it's also, you can also maintain keep that from happening by making sure that your slicer is set not to divide up your curves into too small a segment. Over a millimeter is good, if possible. Just make sure your segments aren't too small.
All right. So what are your plans for Murph, and are you planning on dropping any big news or bringing any big ideas to Murph?
My plans for Murph are to go and kind of just take it all in and enjoy it, see what's going on, actually see the 3D printed car race this time. And just kind of catch up with everyone. I haven't made, Murph hasn't been really a venue for a lot of big announcements, or hasn't been for me. And I wish I could say that everything lined up just perfectly to be able to say that, hey, here comes the big release. I can say ahead of Murph that now is a great time to be testing Marlin 2.0, because it is, it's getting there. It's really, I would like to know what the holes are and what needs to be filled in. So ahead of Murph, I'm just going to say that Marlin is ready for testing, but your mileage may vary. It's actually been maturing and in a pretty good state for a while for a lot of these platforms, and people have been using it and getting good results. And so, I just worry about like those little holes and like in the newer platforms, like the big variety of STM32, and also the fact that, as we're trying to target these, the libraries that support them are a moving target as well. They're always changing. So, but the good news is that Marlin is here to stay. It looks like it's running well on a lot of these boards. And I would love to see if I'd love to be able to say that some vendors are going to start using it, but since it has no official version release yet, I can understand if they would not, and it's probably better if they do not, because it's nice to be able to have a reference point rather than this commit number or whatever. So I'd like to be able to say we have a version, and but it would be premature, I think, to put a version number on it at this point and say this is 2.0 release candidate one. So yeah, I will have stickers.
What?
But only a few. So you know, you may have to get yours from Practical Printing or someone else.
I have one of those reserved right now. I'm reserving a sticker.
All right, I owe you one because I got this sticker.
That's right. I will be there. I will be there Thursday night, so I better get one.
Yeah, you got it. I'll make sure to keep a few for all my special friends.
All right. Howie said he's working on the IDEX, but he's having trouble with both the Dual X and the Dual Z. So, where would be the best place for him to go to, maybe put in, say, hey, I'm having trouble with this or blah blah blah.
Well, we have a Discord now, so there is actually a link for that posted on the Marlin firmware page somewhere, maybe in the README.
Well, if you will, send it to me in like Twitter, and that way I can paste it in the description. So it'll be down. You can't see me. I've got it locked on Scott. It'll be down below in the description. There
are a couple of Facebook groups. One of them, which is I moderate it, and then there's another one which is called Marlin Firmware for 3D Printers, in case you're using your Marlin on a 3D printer. And that one is also very active, and both of them are very helpful as far as working out the kinks. And if there turns out to be a bug, then we, of course, go to GitHub and file a bug report with our issue queue, and let us know what the bug is, and we'll try to work it out. Because I know there's been a lot of attention paid to this lately. So I would say, make sure to try the latest bug fix 2.0 if you're not already, and let us know what's going on. Because the person who's dedicated to this, there's been. I know that he got to a certain point, and I know I think he might have left it with some kinks and wanted to get back to it. And so it would be good to know if that's still the case, and I'll let him know to, get on that.
All right. Well, Scott, we always end with this type of question, and Gustner asked it early on, but
sure.
We've been going for an hour and 12 minutes now, so I'll give you a little bit of time to answer this one, and then I'll tell everybody bye. And that's right.
All right.
Yeah,
All right.
Do you think a filament diameter sensor could improve FDM 3D printing, or what do you think you'd like to see come along in the 3D printing world that you think would just make it that much better?
Filament diameter sensor is an interesting thing. There actually has been a long-standing feature in Marlin to detect the width of the filament at some micron level, and then pass that on, and then stick it in a buffer. So if it's like, if the sensor is here and your nozzle's here, you want to know it's 12 centimeters away. So the buffer to keep track of, each centimeter, how wide was it? So by the time it gets to the nozzle, you know that this part of the filament was this wide. And so if you know the width, the volume, how much filament is coming in, unless there's a bubble inside your filament, the volume. And so from that, you're supposed to be able to then attenuate the movement so that you're getting the right volume. And things like that, if they're very accurate and they really work, probably can help somewhat, because you're getting a consistent volume, you're getting what you want, you're getting the control you need. So if there are sensors that can do that and are that good at it, you can turn it on, you can see it, you can give it a try. There are others that will other features that'll actually, if you're moving a certain amount of volume through the nozzle, it'll up the temperature, which is, because you're eating up a certain number of BTUs or ohms through your, or watts or whatever as you're putting the filament through. You want to replace those watts, and so you just want to basically keep up with it. And so things like that will produce more consistent results, or have the potential to produce more consistent results. The problems are you're dealing with a physical system, and there's latency between the heater and when the temperature sensor picks it up, and it has to do a certain number of samples, but they're pretty rapid. But the actual heat moving from one end of the block to the other may be slow, and there are other factors that can come into play. You may be using linear advance, which tries to maintain a consistent pressure inside the nozzle and use up the pressure at the end of moves or on corners, and then keep that pressure moving. And that can be, tuned in just the right way, but under one condition and with a certain print, it'll work great. But then you do some other print with different features, and it doesn't work as well. it can be very hard to tune things just right for all situations. So the real trick I've found is to work with small calibration objects, tune them as well as you can to within a certain set of parameters, then move on to real world tests of actual objects that you might print and compare the results, see where the gaps are, and then find a happy medium between those idealized results for your calibration objects and your real world results. And if it involves features that tune the temperature or measure the filament diameter, that kind of intelligence can only go so far, and you're adding more and more to the complexity of the system, therefore more and more failure points. The simpler you can be, the better, I think. Get really good filament, good quality filament that has a fairly consistent diameter. Work with, model and work in a way that can tolerate a certain amount of, variance in the amount of filament that comes through. 2 to 3% wouldn't be out of the question. Do your outer walls using, say, the trick where it does 2 outer walls at a thinner height, and then before it does all the inner stuff at a normal height. You'll get nicer looking outer walls that way. Basically, there's all kinds of tricks you can employ within the slicer and within the software to sort of mitigate the fact that you have a physical system that is imperfect in probably lots of ways. Of course, tighten everything, make sure everything is as solid as it can be, and then work from that baseline. And and again, the firmware can only do so much. There's the classic example of if your gantry is twisted and you're trying to probe the bed, as you move along, the probe is going to be changing its angle. Therefore, the probe itself is changing, and therefore it no longer correlates to the nozzle, and you can't rely on those results. The only solution is nothing in firmware can fix it. You have to actually physically fix your gantry or whatever it might be that's causing it to go out. So sometimes, you can do certain things in firmware, but when it comes to the physical system, do as much tuning there first as you possibly can.
All right. All right. Well, listen, man, I want to thank you for being here. I'm going to tell these nice folks goodbye, and I want to thank all of them for the great questions and being so involved in this. I will let you know that I'm currently, right this minute, other than the link that I asked Scott to send me, I am pasting all of Scott's links down below, so you can go and see him everywhere you want to see him. Twitter, YouTube, you name it. He is there. Now, Scott, where can they go to support you?
I have
support your efforts on Marlin.
Well, I've got a donation options page now, because there are many. There's so many choices, and people may have different preferences of which service they want to use or not use. So I put up a page on my website at thinkyhead.com/donate -to-Marlin. It's also linked from the front page of thinkyhead.com in a very non-prominent way on the left. But you can pick one of those options. There's PayPal subscriptions. There's Patreon. With Patreon, I'm trying I want to do more exclusive videos to update my patrons about what's going on, to make that a sort of a more value-added proposition. Because people expect that from Patreon, and I want to basically also, I've tried adding other special privileges, like give you a Discord link there that gives you access to areas of Discord that aren't accessible to others, but it's hard to find extra value there, because I might be able to answer a question or two. There's like a voice room that you can do voice chat in there, but Discord isn't super exciting. But basically, there's also an option which is called Flatter, which I tried out, but people don't quite understand it, so I don't necessarily recommend it unless you're already using Flatter and like it. But yeah, go to that page, and there's definitely a few options. So
I actually took out all the links I had just pasted in there, because you have this great page called Follow that has them all.
Yeah.
if they go to this one page, they can follow you everywhere and see everything else.
just Google for Thinky Head and you'll find me.
Oh yeah, absolutely.
And because I'm the only one on the whole billion internet with billions of usernames. So it's me and Raybo Direct. We're the only ones who have it. So
all right. Well, Scott, I want to thank you for being here. I appreciate you taking your time out, dude. I can't wait to see you at Murph. We'll share a beer. We'll clink those glasses. I promise.
Oh yeah, it'll be great to see you.
All right, buddy. I'm gonna swap over here and tell them goodbye, and I'll be back with you in just a second when we're done.
All right, cheers.
All right, Country Club, I want to thank y'all for being here. You've been watching Scott Lahteine, the curator, master, guru of Marlin at the moment. And I do want to appreciate you all for the questions and Scott for taking his time out. If you want to find out more about Scott, how to follow, how to support, all of that type of thing, and he's going to send me the link to his Discord. The link for thinkyhead.com/follow is in the description, and it's got a whole bunch of links that you can go to, Twitter and all this other stuff. But thank you all. I appreciate it, and we will see you tomorrow night on Country Time. Thank you, Country Club. We'll see you then.